Okay, I'm still waiting for the CentOS to boot up. It is booting in parts. There you go. Okay, guys, so this is the desktop of CentOS with the wallpaper of Cloudera. Okay, so this is the uh, desktop. Now, by default, as soon as your desktop kicks up, Mozilla Firefox opens up. Now, if you do not see Mozilla Firefox opening up right away, you can click on the Mozilla Firefox button here, which is here. So as soon as you click, it will redirect you to this particular start page. This is the home page of Mozilla Firefox. Right, so in the meanwhile, what we will do is we will open the tutorial material that I had sent you. Let me quickly search it. Oh yeah, it's here, MapReduce in Cloud. Okay, so this is the material that I had sent you. So I can skip steps 1, 2 and 1, 2, 3 and 4 because we've already done the step 4, that is open Firefox in the virtual machine and so on. Okay. Okay, let's check whether the name node is up or not. How do we check that? Localhost colon 50070. Here you go. Oh yeah, name node is up and running. Great. So Hadoop is already started. Now the home page, what it does is that it will start the entire Hadoop configuration. Whatever is pre-installed, comes pre-installed in this box. All the daemons are started when your page, this particular page boots up. Right, so let's start from step number 5. Remember, we are skipping step 1 to 4 because it's already done. That's what we've done till now. Step number 5, open the terminal and do the following to run MapReduce. Okay, let me open a terminal. This is a shortcut for terminal. Let me expand it. And what is it that I have to do next? Create the input directory user Cloudera word count input. Okay, so this is how I have to do it. Sudo su hdfs. What does this mean? Sudo su hdfs means that you're trying to access a user called as hdfs. So let's do that. What's your default user here? The default user you are right now is Cloudera. But we do not want to be Cloudera anymore. We want to be the user called as hdfs. So let's do that. Now we are into the bash shell, bash 4.1 version. What's the next step? Hadoop fs mkdir /user /Cloudera. This command creates a folder called as Cloudera within the folder called user. Let's do that. Hadoop fs mkdir /user /Cloudera. And let's wait till Hadoop gives us a response. Oops, so the file already exists. Let me check whether the file already exists or not. I think I have already opened. Okay, so how do I browse the file system? Utilities, browse the file system. Okay, so there's a folder called user, and yeah, Cloudera already exists. Okay, so the folder Cloudera is empty. However, the folder called Cloudera actually exists. Fine. So now that it already exists, what do we need to do? Hadoop fs chown Cloudera /user /Cloudera. So what does this mean? Now we have created a folder called user /Cloudera with the user called as hdfs, right? In this particular step, we are changing the ownership. Chown stands for change ownership of this particular folder, that is user /Cloudera, to Cloudera. Now if you observe, the name, the folder called Cloudera is owned by Cloudera and the group is also Cloudera. Guys, the material that I had prepared was for a previous version wherein such a folder was not created by default. We have to create that folder. But since this is the latest version, I think it ships with a folder already being created. So we can also skip steps till here. Okay. Why? Because the folder is already created and the owner of the folder is Cloudera. Now we are exiting from that particular command prompt and then we are doing something else. Let's see what we are doing. Let me quickly exit from the bash. Yep. Okay. Now sudo su Cloudera, meaning which I will be the Cloudera user. But since I'm already the Cloudera user, it really does not make sense. So see, this is what I'm having to do. So since I'm already the Cloudera user in this case, it does not make any sense for me to write this particular statement. Let's see what next I'm doing. Hadoop fs mkdir, okay, so I'm basically creating a directory, /user /Cloudera /word count. Okay, so I'm creating a folder called as word count inside the Cloudera directory. Next, space /user /Cloudera /word count /input. So basically I'm creating two folders. One is input inside word count folder, which is inside Cloudera, which is inside user. Fine, so let's go ahead and do that. Hadoop fs mkdir /user /Cloudera what was that? Word count. Okay. So this is one particular directory. The second directory is, we are going to create another directory inside the newly created word count directory. You can create it in a single step or you can create it in two different steps. /input. Okay, so I'm basically creating two new directories. Let me wait for the response. Okay, so it's done. Let me check. So there's a folder called as Cloudera. Let me click. There you go. So you see a folder called as word count that I just created and a folder called as input that I again created right now. Fine. So what next? Create sample text files as input and move to the input directory. Fine. So let's just create some two random files. Echo good morning. Let me write it to file 0.txt. What does this command basically do? Oops. Okay, hold on. Okay, so for some reason it's not accepting an exclamatory mark. So let's create a file with the content, whatever. Good morning. I'm writing the output of echo. See, this command just prints me good morning, that's all. If you see the result of this particular command, it just prints me good morning without the inverted commas, without the quotes. So now let me write this particular output to a file called file0. Done? Okay. Similar fashion, let me create another file. To file1. And another file to file2. Okay, so in which directory am I? In local. Okay, right. So if I do an ls minus ltr, these are the files that I see. Let me view the content of the file one by one. See, so if I read the file called file0, the content of the file is good morning. So file1 says good evening, and file2 says good night, good evening, and good morning. Right, so the next step that we have to do is, remember guys, the files that we've just created are inside the CentOS, that is, it is inside Linux. Now we need to push these files into Hadoop. Okay, but before we do that, we are doing something else here. No, we are doing the same thing. So Hadoop fs put in the sense it puts the file from your local to HDFS. When I say local, I mean Linux local, not your Windows. CentOS is your local, and Hadoop is of course Hadoop. So Hadoop fs, Hadoop file system, put file asterisk. So file asterisk means that you're pushing file 0, file 1, file 2, file 3. So it's a meta character. Whatever starts with file, all those files you're pushing it to this particular directory inside HDFS. So let's try this. Hadoop fs. Now put is a command that you can use. Alternatively, you can use copy from local as well. Copy from local in the sense it copies from your local machine, that is your CentOS, and puts it to your Hadoop. So Hadoop fs copy from local. What is the name of the file that we want to push? File. So all our files start with file, right? So file 0, file 1, file 2. So I use a meta character file star 2 / user / word count. Oh, sorry. Cloudera / word count / input. Okay, it's done. Let's check it in the UI. See, I've got file 0, file 1 and file 2 inside this particular path. Let me check the content of file 0. Okay, so I have to only download it. I don't think I can view it, is it? So it's an update in Cloudera CDH5. The version that we are using right now is CDH5, Cloudera's distribution of Hadoop version 5. So there are quite a number of changes that have been made. The last version, the most stable version, was CDH4 before. Okay, hold on. Okay, so let me save the file. I have saved the file. Let me open it. So this is the content of the file called file0. So you've got this fancy new thing rather. wherein you can click on the files, download it and view it. Now if you see, you'll find the details of all this, of each and every file. The name of the file is file 0. The block size in HDFS is 128 MB. So this is opposed to the 64 MB by default block size. Cloudera CDH5 goes ahead with by a default block size of 128 MB. The replication factor is 1. By default, replication factor in a Hadoop cluster is 3. But since this is just a demo version, that is, since this is just a VM virtual machine, the replication factor is just 1. There is no point in having 3 replications in the same machine, right? So they have gone ahead with replication factor of 1. This is the size of the file, that's 13 bytes, and the owner of the file is Cloudera. The group under which the owner comes is again Cloudera, and this is the permissions that you have for the file called file 0. Okay, now what's the next step that we need to perform? Right, so once we are done with copying the file and putting it into Hadoop, we have to run this particular application, cd/user lib Hadoop MapReduce. Let me just copy the path and let me paste it here. Okay, so I'm inside that particular path. CD is just change directory. I'm inside this path called user lib Hadoop MapReduce. Now why am I going inside this particular path? The reason is the folder called Hadoop MapReduce ships with certain example jar files. Now in this particular activity we are not going to sit down and write MapReduce code because that's tedious. Rather, what Hadoop does is that Hadoop ships with certain example jar files. And what is a jar file? Java archive files. Now what does this mean? It's just a collection of class files put together. Okay, and what does this indicate? These are certain MapReduce codes pre-written and combined and stitched together into a jar file, right? So the name of the jar file is Hadoop MapReduce examples.jar. So this is the jar file that we are going to run. In the next class, we will be seeing the content of this jar file. What does this contain internally? It definitely contains a map class, a reduce class, a combiner class, and a driver class. So in the next class, we'll be seeing what is the code and how is it written and so on and so forth. But in today's class, all we are concerned is how to run a jar file, a MapReduce jar file through the terminal in Hadoop. Right, so just for the sake of convenience, let me do an ls-ltr. You can see a lot of jar files in this particular directory. Now the jar file that we are concerned about is this one, Hadoop MapReduce examples.jar. Right, so what are we doing here basically? We are running the jar file. Now this is the command. Let me first copy it, guys. I'm going to run it now. I'm just going to paste it right now. Okay, hold on. Right, so let me explain the command. Hadoop jar. So this indicates that I'm going to run a jar file within Hadoop. So Hadoop space jar and the name of the jar file. What is the name of the jar file? Hadoop MapReduce examples.jar. So I'm going to copy it and I'm going to paste it. Space. So Hadoop jar and the name of the jar file. What am I going to do with this? I want to run a word count example. Okay. So the objective of this entire exercise is to run a word count on the input files that we have just created. So the argument here is word count. So word count is what I want to do. Next, okay, so Hadoop jar, the name of the jar file, and the argument, that is what I want to do. Next, I have to give the input, that is the place or rather the files on which I have to do a word count, and the output, that is where do you store the output. So these are the two things that I have to give. So /user/Cloudera/ word count slash input, right? So this is the path where we have our input files, isn't it? So this becomes our input path. And what is the output path? You can create any output. You can give any path as the output path, wherein the MapReduce code would be storing the output. So we'll just create an output in the same directory, slash Cloudera slash word count. Now instead of input, let me change it to output. Okay. Now the template is simple, guys. Hadoop space jar space the jar file that you want to execute, space the argument that you want to run, space the input, space the output. Okay, now let's run it. You'll be seeing a lot of stuff that's being executed. Okay, so connecting to something called as resource manager. We will explain each and every term in the next class, don't worry. Now, total input paths to process 3. What does this indicate? It indicates that you have 3 input files, that is file 0, file 1 and file 2. Number of splits 3. Let me explain this in a later class. Submitting tokens for the job. So basically a token is generated and it is submitted. Submitted to whom? That's a story for another day. Submitted application. Now it creates an application, it submits. Now you can click on this particular URL to track it. I can click on this and track it. So this is the name of the job which it has started running. Now if you see this, as of now the current state, it has just started to execute MapReduce. Even mapping is not done. So once the process of map is completed, the process of reducing will start. Fine, so let's query it in real time. I've just clicked on this particular URL. Have I? No, I haven't clicked it as yet. Yep, I have just clicked it. So this is what I have to click in order to track the job. Right, so I've just clicked it. Let's see what happens. There you go. So you see the status in real time. This is the job ID and this is the argument that you've done. So word count and the status is running. This is the progress of map task. Okay. This is the progress of reduce task because reduce task hasn't started as yet. Reduce task will start only after the completion of map task. Only after the entire mapping is done will the reduce task start. So you've got 3 inputs. So you've got 3 maps in total. Now, it has already completed mapping of 3. Reduction will start. If you see the ratio here, you have got 3 maps and you've got only 1 reducer, right? So that exactly proves our theory classes wherein we were clearly telling that the number of, if you see the ratio of mappers is to groupers is to reducers, mappers will be the maximum. Now, how many number of inputs you have, so many number of maps you will be having. Groupers will be less and reducers will be more than number of groupers but less than the number of mappers. In this case, we are not using any groupers. Fine, so here it's done. Now let me just refresh this page. MapReduce is done, guys. I'm trying to refresh this page so that it, yes, see, here you go. Job name, word count, username Cloudera. This is the queue. State, it's succeeded. That is, the job is a success. Whatever we've done is a success. And you've got other statistics as well. Great. Now you can see the statistics here. The number of map tasks were 3 and all the 3 were completed successfully. The number of reduce tasks was 1 and even that was successfully completed. Attempt, maps, 0 failed, 0 killed, all the 3 were successful. Reducers, 0 were failed, 0 were killed, and 1 was successful. So if you figure out that there is any errors happening, you should be able to see it here. Okay, fine. So now let's read what is happening here. Right, so you had map 0%, reduce 0%. Next you had map 67% and reduce 0%. Next, map was 100% completed, and then reduction would slowly start. After map was 100% completed, reduction starts, and then it also gets completed 100%. Here are certain file statistics which you can read it and understand what's happening basically. I want you to understand it in a clear-cut fashion, guys, because only if you understand this will you understand how MapReduce works at the back end. Okay, these are fairly simple, you can even understand it. Okay, now let's query. MapReduce has run. I have given it the input and I have given the output directory. Let's figure out. My argument was word count. Now where is the word count? What has happened? What is the output? Let me check. I can check it from the back end or the front end. We will do both these things. When I say back end, it's through the terminal. Now whatever I'm doing here is from the back end. The front end is through the UI. Now let me do it from the front end, that is the UI, and then through the back end. Okay, now let me go to the browse the file system directory. Okay, so I've got input, a directory. With an input I have got file 0, file 1, file 2. Now if you remember, I had asked MapReduce to create a directory called output, which it has created. When I click on output, I've got two things. One is a success folder, the other one is a file called part-r-50. Now this is just a folder, and this is just a log file basically, not a folder, I'm sorry. So this is a log file which says that guys it's success and so on and so forth. Whereas this is the file which has got the output. Let me check the file. I'm saving the file and I have opened it. Now if you see, this is the file which shows the word count. Evenings, the number of times the word called evening occurs is twice. The number of times the word good occurs 5 times. The number of times the word morning occurs is twice, and the number of times the word night occurs is once. Remember, the input files were 3 files, part 0, part 1 and part 2, right? So this is a cumulative summary of all the 3 files. You can cross check it if you want. So see how neat it is? Now this is how MapReduce works. Now let's check the content from the backend. Hadoop fs cat in the sense it will read the output slash space slash user slash Cloudera slash word count slash output slash part hyphen r hyphen 1 2 3 4 5. Yep, this is the name. Or is it 6? No, 5 zeros. Okay, so this command should, yes, there you go. This is the content of the file called part-r-50. There you go, guys. What we've done right now is we've essentially completed running a MapReduce jar file on Hadoop. So there you go. The next step is just to examine the output. You can examine the output. Thanks for watching, guys. Have a great time. Bye-bye.